Hello and welcome back to another edition of the Medeek Engineering Plugin. My name is Nathaniel P. Wilkerson, and today I wanted to discuss lateral stability in beams a little bit with the regards to this extension, and also just in general the concepts involved and how we apply some of that to the settings and options that are here in this extension. So to get started here, I just went ahead and drew a very simple beam, applied a distributed load on it, and put 3 supports underneath it. So what we have is a multi-span beam with 2 spans. So just to begin with here, this is going to be a little bit of a technical discussion. So just to forewarn those people that are not engineers like myself, and hopefully most of this doesn't go over your head, but I think if you listen carefully, you'll get the main gist of what I'm trying to explain here. So basically, when you have a beam, the issues when it comes to bending are that you will potentially get what's called lateral torsional buckling. So basically, as you load the beam in bending or put a load on it, as shown, what's going to happen is if the beam is not braced, along its length, it will actually fail quicker, usually in buckling, than it will fail actually from the bending forces alone. So what I mean by that is I'm going to go ahead and unhide just like a little diagram I show here. So typically when you load a beam like this in what's called the strong axis, or along its the depth, down on the depth of the beam, this is what's called strong axis bending. And as you can see, the beam is going to have a propensity to be stronger in its depth than it will be in the much more narrow laterally, right? So that's what happens there is basically you get the kind of what they call lateral torsional buckling, what I kind of call side sway. So the beam wants to kind of sway sideways one way or the other, and specifically that effect will be mostly pronounced on its compression edge. So if you load a beam like this, what's going to happen is the bottom of the beam is going to be in tension, the fibers of the beam, and then the top of the beam, the fibers will be in compression, right? So that compression side of the beam is where our main concern is. And so what happens is that compression side will want to sway one way or the other, and you can try this like with a ruler or something, or even just a board like this if you've got a big board, and you can see that effect quite quickly. So that's kind of what we mean by lateral torsional buckling, and I'll go ahead and just hide these now. So that is the issue with beams like this. So basically you want to laterally brace them, and typically like with a beam like this, if you've got a floor sitting on top of it, maybe you've got joists that are spaced every 16 inch on center, that will provide the stability or the lateral bracing perpendicular to the length of the beam, right? So that's why it's called lateral bracing. And if it's braced, maybe 16 inches on center or even 2 foot on center, you're going to basically call that continuous bracing, right? Okay, so that's where we're going to get into the settings now with the extension. Okay, so what I'm going to do is I'm going to go ahead and hit the engineering button here and select this beam. And I'm going to show you now right here at the top under design options, you're going to see lateral support T and lateral support B. So T obviously stands for top and B stands for bottom. So that means the T is like the bracing along the top edge of this beam, and the B is for the bottom edge, right? So first off, we're just going to start with full lateral support. So that assumes that we've got full support along the compression edge or top edge of this beam and the bottom edge of this beam. And if we do that, let's go ahead and pull down this. Okay, first off, before we even get to that, let's talk about the moments, right? So what's happening here is we've got just a distributed load along the full length of that beam. You've got what I call positive bending, max positive bending, at the kind of the mid-span of this segment of the beam or span of the beam. And then, of course, you're going to notice right here at this support, you're going to have your max negative moment. So basically, when you think about that, you can almost imagine that this beam, because of the reaction of that support, it's being bent the opposite direction as in the middle of the beam here, or the middle of this first span. So it's trying to, bend it upwards in a sense. Whereas in the middle of this first band, it's kind of bending it downwards. So that's kind of what, if you can visualize that, you can understand what's going on with these moments. Okay, so and because of that, with a multi-span beam, typically you're going to have a max moment, or a max positive moment and a max negative moment. So that is why we have to actually consider what's going on both the top and the bottom edges of this beam. Okay, so in this case, we set it to full lateral bracing, and you'll notice here with the bending, you're going to see what's called the beam stability factor, or C sub L. Right? And for both negative bending and positive bending, you're going to see that factor is set to 1. So basically, if the beam is braced laterally enough, that factor will go to unity, or 1, and it will not decrease the allowable load or stress permissible in the beam. Okay, so what happens is as we want, or as we have unbraced beams, that factor is going to go from 1 down, right? So maybe 0.9, 0.8, even 0.7. It's just going to get lower and lower as the beam becomes more susceptible to that lateral torsional buckling. Okay, so basically with the full lateral bracing on both top and bottom, you're going to see that goes to 1. And of course the equations, very simple calculations. There's not a whole lot going on here. And yeah, so let's go ahead. And now what we're going to do is we're going to take a look at all the options we have here. So we're going to assume that now, let's say that we've got bracing at 2 foot on center along the top. And now we're going to assume that we have no bracing, or it's laterally unbraced along the bottom edge, which can be a pretty valid assumption. I mean, for a lot of beams like this situation, if you've got decking or sheathing up on top, it's probably going to be braced along that top edge, and then the bottom, if you just have an open beam, chances are it's not going to be braced along this full bottom edge. And this intermediate support may be like a post or a column, where it's not really providing any lateral bracing. I mean, it is providing an upward force, but the top of that post may not have any bracing to prevent it from swaying sideways, or horizontally perpendicular to the length of the beam. Let's go ahead and update on that, and then just go ahead and calculate that again. Okay, so again, the moments aren't going to change, of course. That's all going to stay the same. But if we come down here now to the bending, you're going to see, first off, the negative bending calculations are way more complicated than previously, and the positive bending, well, again, it's complicated too, but the thing you're going to notice is that we are now calculating what's called this unbraced length, right? And you can see that right here, right below the negative bending. I don't think you guys can actually see my cursor, which I apologize. I wish I could figure out how to make that visible. But anyways, underneath the negative bending title here, you're going to see what's called the unbraced length. So that's 144 inches, and this is for the negative bending, which is regards to the bending that's happening along that, or the bottom edge issues with the compression, right? And then with positive bending, you're going to see that, of course, we set that to 2 foot on center, so that's 24 inches. Okay, so, and I really want to stress what's happening here with our C sub L, our beam stability factor. So with this set to 24 inches, notice that it's 0.98. So it's increasing almost to 1, right? And so in most cases, if you've got 16 inches on center, or 12 inches on center, or even 24 inches on center, usually you can assume C sub L equals 1. I mean, it's pretty close anyways, 98% there, I mean, so, and that's why, let's go ahead and just show you what I mean by that. Let's go ahead and set that to 1 foot on center, okay? So let's go ahead and update that. Let's go ahead and run that again. And you're going to notice now, we scroll down to the positive bending. See, with 12 inches unbraced length, we now have 0.991, right? So, yeah, it's approaching 1. And, and for all cases, I mean, this is probably as good as 1. So that's why we can make that assumption usually that C sub L is equal to 1. And all of these calculations where you got to, calculate the slenderness ratio and all that, it pretty much just goes away, and you just set that to 1. So anyways, another thing I want to note, though, is with, so I think, what did we do? We set that to laterally unbraced, correct. So laterally unbraced basically means that none of these, none of the supports, intermediate supports are providing any sort of bracing, but we do make the assumption that the outermost supports, right? So we've got S3 here and S2 on the very outermost. So we do make the assumption that those are braced both top and bottom. If you don't have, well, let's put it this way. At a very minimum, I think you need to have 2 brace supports at the ends of the beam. Otherwise, if you don't, I mean, the beam is just going to flop over. And I mean, you can try this. If you ever framed up a floor, like just doing construction, you'll notice that until you actually got those joists framed up and the tails of them, basically tacked into the rim joists, the joist is going to flop over. So again, that's the assumption. We have to make that assumption that the 2 outermost supports are secured and are braced both top and bottom. And so that is why you end up with this negative. For negative bend, you end up with 144 inches or 12 feet unbraced length. And if you go up here to the top, you'll see, that is the length between our 2 outermost supports. So that is the assumption we're making, just to be clear on that. All right. So basically, you got quite a few options here. Let's go through a few more of them. So basically, you have the full lateral support, which means that you're bracing at an interval that makes it approach 1, which is whatever. Let's just say it's every 6 inches. And then you have all these options for lateral bracing at different unbraced lengths that you can set. And what happens actually is if you set the lateral unbraced length to 10 feet on center, it's actually going to look at your longest unbraced span and compare against that, and it's going to take the shorter of the 2, right? So if you set it like 20 foot on center here is that lateral unbraced length, it's going to actually ignore that and just select 144 inches because this is greater than that value, if that makes sense. But basically, though, as you get smaller, then these will override any unbraced span length that's in the beam. So you could be setting it like to say 4 inches, or not 4, just 4 feet on center. Let's go ahead and try that. And now you're going to notice that the unbraced length on the negative bending should be 48 inches. And let's go down here, and you can see that, yes, the unbraced length is 48 inches, and you can see, your C sub L reflects that value. Okay, so that is pretty much the basics of lateral bracing in the extension. And again, because we end up with a multi-span beam like this, you end up kind of with negative and positive moments, and that's why we separate out the top and the bottom lateral support. We could, combine them and say, well, we just top and bottom, but then, things get a little bit more complicated than that. Okay, so the next thing I want to talk about is the last one here, really, which is braced at supports. So what's happening with that? Let's just say that this one's laterally unbraced. Okay. So if you set it to braced at supports, that will mean basically that along this top edge, you have bracing specifically at each support. Now, of course, the 2 outer supports will automatically brace automatically, but if you have multiple mid-span supports, then you'll have bracing at those specific points. And in this specific case, we basically got 8 feet on this side and 6 feet on this side, I think is what it is. Let's go ahead and run the engineering again. And what it's going to happen is it's going to be looking at this moment and saying, okay, where does this maximum positive moment occurs? And it occurs in the first span. And so then it's going to, if we go down here, we will see the positive bending actually. Sorry, I'm getting lost, is 84 inches, right? So that makes sense. The unbraced span, the first span is 84 inches of length, and that's where it found the max moment, and so that's what it's going to use. Now, if we set this to unbraced, it will then use that full 144 inches of the full beam span, right? So you have that option. You can set bracing at the supports, so you basically have bracing along the top edge along the supports, or you have full lateral bracing or laterally unbraced. Okay, so now there are situations though where you may have more than 3 supports. You may have 4 supports or 5 supports, right? And you may want bracing at a specific support but unbraced at all the other supports. And that is actually where we get into the blocking. So what you can do is you can edit one of these supports. So if I go here, you'll notice that there's an option here for blocking at the support. So if I turn that on, okay, let that think for a second. Okay, so with the blocking enabled on a support, you're going to see kind of like this little dashed line shown on the sides of the beam or the center of the support there. Okay, so that basically helps you know, indicates that you have blocking enabled for that particular support. So with the blocking enabled, basically what it's going to do, it's going to treat this beam as being supported top and bottom at this specific point along the beam length. So even if you have laterally unbraced specified, which we're going to do now just to show that, laterally unbraced. Okay, so if we go ahead and run that with that, you should see both top and bottom that 84 inches is our laterally unbraced length, and which it is. So we notice here LU is set to 84, both negative and positive. So right now this particular example is a little overly simplistic, where this, you know, kind of would show why that would be important. But let's say that you have, you know, multiple supports and you want to have, you know, specifically lateral or bracing along this support, but maybe it's laterally unbraced at the bottom on these other 2 supports over here somewhere. You know, so you can kind of mix and match and get the bracing. It gives you enough flexibility, I think, just to get the bracing kind of fine-tuned as to what exactly you need for your specific situation. Anyways, so that's pretty much it as far as all the options with lateral bracing. We have the ability, you know, to set full lateral support, braced at the supports, and laterally unbraced, and then of course all of these kind of preset values if we want to set the unbraced length at those values. And then of course you can basically override, in a sense, and set bracing at specific intermediate supports. And again, remember, at the outer supports, we're always braced laterally top and bottom. And just a reminder on when you set the blocking, you are specifying top and bottom bracing at that particular support. Anyways, that's pretty much it as far as this goes. I don't want to get a little long-winded with some of my explanations, I think, but I just wanted to cover that and give you guys an overview of all the options when it comes to bracing your beams, and just a little understanding for those that are not engineers is why we're so concerned with this. So hopefully that's helpful, and if you have any questions, give me a shout, and I'm always available by email, or you can even give me a phone call. So we'll talk to you guys later. Thanks so much.